For 6.3, we are discussing the distance formula. Well, the distance formula is a form of the Pythagorean theorem. It's a little bit kind of weird, but it is part of the Pythagorean theorem that will help us find the distance between any 2 points on our x and y axis. So, as we learned before, we can find the distance horizontally by subtracting the x's. So we could find this distance by subtracting our x's. And we can find our distance vertically by subtracting our y's. And we also can, eventually working in the Pythagorean theorem, we can actually figure out how long our diagonal line segment is, our hypotenuse, so that we can figure out what the length is, which is ultimately what our questions are going to ask us for. So there's a formula we can use that is a form of the Pythagorean theorem. It's our distance formula, and it says that our distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And we can utilize this formula to help us figure out how long line segments are. So we're going to do a couple of the problems here, and then we're going to do a couple of the problems from the checkup as well. So it asks us for the first example to find the distance between the points -2, -3, and 4, -3. So we're going to label our points, because remember our formula was distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we need to label our points as x1, y1, and x2, y2. It doesn't technically matter which one you label as which, but whatever one you label as x1, you have to name that coordinate y1. So for example, you could not do this as x2, y1. That would not work. That would be a very bad thing. So whatever the first one is, so this one would have to be x2, y2. So our formula, our distance formula, says that our distance equals the square root of, parentheses, x2 minus x1. Well, x2 is 4 minus x1 is -2 squared plus y2, which would be -3, minus y1, which was -3 squared. And at this point, all you really have to do is type this in the calculator. So we're actually going to work this one out by hand, just so you can kind of see what happens. So a couple things you need to know. Anytime you have something like this minus negative thing, that really becomes a positive. Because 2 negatives in English and math makes a positive. And that's going to happen in both parentheses. In this case, it does not always happen, but in this case it does. So we're going to work this out by hand. Well, if we add 4 plus 2, we're going to get 6 squared plus -3 plus 3 is really 0 squared. So that becomes the square root of, well, 6 squared is 36, 0 squared is 0, and the square root of 36 is 6, so that tells us the distance between these two line segments is 6 units. So we're going to skip down and we're going to go over a problem. We're going to do the distance between -1,8 and -2, 2. So again, our distance formula, and you don't have to write this every time, but I am so you can see it on the screen, is x2 minus x1 squared plus y2 minus y1 squared. So I'm going to go ahead and label my points as x1 and y1 and x2, y2. And then I'm going to plug it in my distance formula. So my distance formula tells me that my distance is equal to the square root of x2, which is -2, minus x1, which is -1, squared, plus y2, which was +2, minus y1, which was 8, squared. And then if I work this out by hand, I get the square root of, well, let's review. Remember we said this minus negative was really plus a positive. So we have negative 2 plus 1, which is negative 1 squared. 2 minus 8 is negative 6 squared. And negative 1 squared is 1. 6 squared is 36. So we end up with the square root of 37. We cannot actually take the square root of 37, so we could leave that as our answer. Or we could also go ahead and take the square root of it and get a decimal, and that's okay. Sometimes it actually asks you for a decimal. And if it does, then that's going to give you an answer of 6.08. The square root button on your calculator, if you're looking at your calculator, you have a gray button that says x squared on it. And then right above it, you have this little square root symbol, and it is blue. And so you would need to hit the second button and then x squared to get the square root symbol. All right, we're going to go ahead and move on and do a couple problems from your checkup. So number 1 says to find the distance to the nearest hundredth. When it asks for the nearest hundredth, that wants 2 decimal places. That means it wants a number, point, and then 2 more numbers. Okay, that's what 2 decimal places looks like. All right, so our distance formula, they wrote up there for us, which is really nice. So I'm going to take my points and label them as x1, y1, and x2, y2. And again, it does not matter which one you label as x1 and y1 and which one you label as x2 and y2, as long as you don't do x1, y2, or x2, y1. Cannot do that. So we're going to go ahead and write everything out. So our distance equals the square root of, our formula says x2, which would be 3, minus x1, which is 1, squared, plus y2, which is 2, minus y1, which is 4, squared. And you really can plug all of this in the calculator, just like you see it. It's quite simple. And if you do that, you will get 2.83, because we have to round. Now, don't forget to include all of your parentheses. If you do not include them all, you will get the problem incorrect. Number 3. Again, we're just finding our distance. I'm going to rewrite the distance formula on this page because we don't see it anywhere. So our distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, it doesn't matter which point you label as x1 and y1, and then which one you label as x2 and y2. Usually I label the first one I see as x1, y1, but in the end it doesn't matter as long as it's consistent. So we're going to plug all of our numbers in. So we have our distance equals x2 would be 2 minus negative 4, because that would be x1. I will tell you, this is the part that most people get tripped up on, is they forget this minus sign right here. Because this 4 is negative, that is true, but there still has to be a minus sign in the parentheses. That's very, very, very important for you to put that. So you have to have a minus sign in addition to whatever negative signs there are as well. So then plus y2 would be negative 4 minus y1, which is 3 squared. And then if we go ahead and plug that in the calculator, which is probably most likely what I would recommend, you're going to get 9.22. Again, we have to make sure we round appropriately. All right, number 5, we're going to again find the distance. I'm going to label my points as x1, y1, and x2, y2. My distance formula, just so we have it handy, is the square root of x2 minus x1 squared plus y2 minus y1 squared. And if we plug in our numbers, x2 being 5, so that'd be 5 minus 3, because that's x1 squared, plus y2 is negative 2 minus 4 squared. Then we are going to end up with, when we plug all of that in the calculator, 6.32. So that would be our answer. That would be our distance between these 2 points. So what that means, just to kind of help give you a graphical example, is the distance from here to here would be like going 6 units. So just showing you on the number line, it'd be like going from a little past 6 to 0. These two segments would be approximately the same length, assuming I can draw well. All right, number 7. So this time they've just given us two ordered pairs. So our distance formula is still the same. The distance equals x2 minus x1 squared plus y2 minus y1 squared. So I'm going to label my points as x1, y1 and x2, y2. So I'm going to plug in my numbers. I get the square root of x2, which is 3, minus x1, which is 4, squared, plus y2, which is 8, minus y1, which is negative 7, squared. And we plug all of that in the calculator, we are going to end up with rounded 15.03, and that would be our distance. Lastly, number 9, we're supposed to find the distance between 1, 1 and 9, 9. So I'm going to label my points as x1, y1, and x2, y2. I'm not going to rewrite the distance formula this time because it's easy for us to see on the screen right now. So I'm going to go square root of, it says x2, which would be 9, minus x1, which is 1, squared, plus y2, which is 9, minus y1, which is 1, squared. And again, I would just plug it in the calculator, which is a really easy thing for you to do. If you need help, just feel free to ask, and I will help explain that to you. So when you type that in the calculator, you are going to get an answer of 11.31. So the distance between those 2 points would be 11.31 units.